Okay, hello everyone. So as I mentioned before, I'm gonna send you some videos about Bode plots. So these are the material that we were supposed to see on the class that I just canceled on September 22nd. So I'm gonna send you multiple videos. So I'm trying to split them into shorter videos so it will be easier for you if you want to download it or um, if you want to watch if you don't want to watch the entire thing at once, so this will be a little more convenient for you. So as I said, I'm going to start with Bode plots. So first let's talk about the definition of the Bode plots. So Bode plots are semi-log plots of the magnitude in decibel and phase in degrees of the transfer function versus the frequency. Okay, so basically if I want to draw the Bode plot, I'm going to have two plots. So I'm going to have the magnitude plot, okay, and the phase plot. So you remember that when I talked about the frequency response in the class, we had two different plots, the magnitude plot and the phase plot, right? So here we're going to have these two plots, but the magnitude should be in terms of decibels and phase are in degrees. Degrees. Okay, so let's talk about how we can transfer our unit to decibels, and then we'll move on. So basically, if we have a system like this here, we're going to have some inputs and some output. So at the input side, we have V1, I1, and some R1, and the same in the output that we have V2, I2, and R2. And clearly we know that the power at the input will be P1 and power at the output is P2. So if I just want to find the gain of the system, not in decibels, just the gain of the system, I can find the ratio of P at the output over P in the input, right? But what if I want to find the decibel unit of this gain? So I have to find 10 log base 10 of P2 over P1. So whenever I want to find the power gain in decibels, I have to do this. I have to use this equation. So 10 log base 10 of P2 over P1. But for the voltage and current, you have to be careful that this equation will be different because power is equal to Ri square and power is equal to V square over R, right? We have all these three equations for power. So basically, here we have 1, the power of 1, and here we have 2. So because of these two, we're going to have 20 log base 10 of I2 over I1. So when I want to find the gain of the currents in decibels, I have to multiply that log by 20. And the same thing for the voltage, because here we have power of 2, since the power of power itself is 1. Okay? So basically, in the Bode plots, in the magnitude plots, we have to draw or plot the gain of the system, okay, in decibels. All right, so H in decibel is equal to 20 log 10 of H, which is gain in a Bode magnitude plot. Okay, so let's see how we can draw this Bode plot and where we have to start. First of all, here I'm going to show you the standard representation of the transfer function. So every transfer function, you remember that I told you in class, they have a numerator over a denominator, right? And each of these are some polynomials, correct? So we have some polynomials in the numerator and some polynomials, in the denominator. Okay, so I have some polynomials in the numerator, as you can see, and I have a constant gain of k. I have j omega positive and negative 1. So this positive and negative 1, it means that it can be in the numerator or in the denominator. And then some other polynomials that they have higher orders, right, of omega. So this was the standard representation of h of omega. Okay, so the first thing that we have to pay attention in drawing the Bode plots is that don't forget that all the polynomials should be in the form of 1 plus something. Okay, so either if I have 1 plus j omega over something, or the second order or the third order. So in this class we'll not go further than second order, but our polynomials should be 1 plus some other values. Okay, some other terms actually. So I'm gonna talk about each of these factors here in the numerator and the denominator, okay, and I'm going to show you how we can use those factors in order to draw the Bode plot. Okay, so as you can see, if you look at this standard representation of transfer function, you can see that we may or may not have a constant gain of k, which is a constant number obviously, and we may or may not have a pole j omega to the power of -1 or 0 of j omega at the origin. So this j omega, which can be a pole or a 0, is we're calling it as a pole or 0 at the origin, and I'm going to tell you why we're calling it at the origin. And then we have a simple pole and a simple 0 that you can see they have these two representations. Okay, and then we have a quadratic pole or 0 that goes to the higher order terms. Okay, so we have to use these factors in order to draw the Bode plot. How? As I have written here, in constructing the Bode plot, we plot each factor. So by each factor, I meant these factors here separately, and then add them graphically. Okay, so in the next video, I'm going to talk about how we can draw each of these factors separately for the magnitude and the phase plot. Okay, and then I'm going to add them graphically in order to have our Bode plot. So both the magnitude Bode plot and the phase Bode plot. So I'm going to talk about this further in the second part of the video. Thank you.